Nick Jones, Head of Decommissioning and UK AEA. Nick.
Thank you. Okay, good afternoon, everyone. It's a pleasure to be here to give you an update about the Jet Decommissioning and Repurposing Programme, or JDR. And for others, it may be an introduction because actually we're quite new to the world of decommissioning. So actually it's more about what we've done so far, our ambitious next steps, and hopefully pique your interest to be part of that journey with us. So fusion's final phase, from groundbreaking experiment to global blueprint. So Jet showed the world how to do fusion, and now we're showing them how to finish it. After more than 40 years at the forefront of global fusion research, we're now at the final phase, decommissioning and repurposing. And whilst that might sound like an ending, as many of you work in decommissioning know, it's actually the start of where some of the most difficult challenges begin. Because decommissioning a fusion facility isn't actually about just dismantling hardware. It's more about managing uncertainty, whether that be technical, historical, or commercial uncertainty. If we don't deal with those things early, those are the things that run away and become costs and risks at a later stage. And when we set out a few short years ago to do this, we did a lot of industry engagement with actually many of the organisations represented here today who were hugely open and transparent and very, very useful in helping us sort of pick our next steps. So actually what we're looking to do with this uncertainty is deliberately shift it. So not reacting to uncertainty, but reducing and governing it as early as we possibly can with better information, better decisions, and targeted innovation. So it's not just about taking Jet apart. It's one of the most complex scientific experiments ever built, taking it apart and turning it into a repeatable industrial blueprint for the future of fusion, because of course we have to prove that it can be done. So before I go further, just a very brief introduction. What is Jet? So it has been the world's largest and most successful fusion experiment. It's the only machine to have ever operated at this sort of scale with a full DT fuel mix. It set several world records. It supported the development of its successor, ITER, and it's been the basis of physics and engineering for actually many other UK and global endeavours. And as soon as operations were finished by Eurofusion, it was handed to JDR as a UK government decommissioning liability, with effectively for us a bit of a standing start. And overnight, we actually went from being operators to decommissioners. And through this new lens, what we realised was Jet has evolved continuously. Systems were tweaked, upgraded, modified, and moved over time. And actually, what we inherited was not necessarily what we expected. In all cases, it wasn't that sort of clean, refined, well-defined design. It was actually the result of 40 years of innovation piled on top of itself. And that creates a fundamental challenge. So we're not just decommissioning a machine, we're also now archaeologists decommissioning the history of that machine. And so the instruction came from DESNZ, and at its core, it comes down to three things. Firstly, it's to discharge the UK's liability safely and cost effectively, reduce the hazard and manage that waste responsibly, and thirdly, to build a capability that positions you, UK industry, as world leaders for future fusion markets. And of course, that third point is really crucial to all of you, because we're not just a programme, we are a genuine opportunity to develop new approaches, to prove new technologies, and build a supply chain that can be exported globally. So our success is not just measured in what we don't leave behind in terms of Jet, but actually what we do leave behind in the capability. So what does the challenge look like? Well, here's the Jet estate. It's approximately 25 acres, and it's a complex system. It's sort of buildings, infrastructure, power, cooling, fueling, and in the big building, just over on the right there, is the tokamak itself. And whilst that appears to be a reasonably simple structure, simple so far as simple goes, the rate of experimental change that we've seen over those 40 years just did not consider decommissioning in the way that we now have to consider that. And so what we're dealing with in many cases is sort of incomplete red line drawings, limited or paper-based records, and endless realizations of those evolving changes and configurations over time. So for us, the challenge is not so much a physical one, it's an informational challenge. Our biggest challenge is understanding really what we have so that we can safely and efficiently remove it. But thankfully, you would think that the worst of that uncertainty is where the complexity resides in the tokamak itself. But fortunately, it's not. Of course, this was where there was most scientific interest and where the highest hazard resides. So actually, the information there is pretty good, and the further away you get, the worse that information becomes. So how are we tackling it? Well, we're taking a 4-axis approach. So firstly, the outside-in approach. If you were to come to our site today, you would see a hive of activity, deplanting and demolishing some of those buildings pictured earlier. We're doing that because we're shrinking the estate and therefore our cost and liability using sort of more conventional methods. This is because, like all tenants on our site, Culham campus, JDR is charged accommodation costs, many of which are now to serve buildings with absolutely no purpose or benefit whatsoever. We're busy removing that liability and turning the costs, those operational costs, back into decommissioning capital as early as possible before those buildings degrade and just we get into this vicious circle as an expensive burden. And using that money that we save as early as possible gives us sort of compounding benefits, if you like, and use of that money. We also have the inside-out approach, and this is where we're looking at primarily the tokamak itself. So when you combine scale, history, hazard, and uncertainty, as many of you will know, regular decommissioning methods may not be an option. And that creates opportunity for us as much as it creates challenge. And to solve some of these problems, we know, and they're first of a kind, therefore we have to innovate. We need first of a kind solutions, particularly around areas in robotics and remote handling in hazardous environments. So our plan, this inside-out approach, is essentially to use a remote handling system to take the components out of the vessel, the core, if you like, and then take those to a detritiation facility where essentially we can thermally treat those, liberates the tritium fuel out of the in-vessel components, turning that immediately from ILW to LLW, but also actually recapturing that fuel, so obviously into air, then into water, and then from water back into theoretically a useful source that can go back into fusion experiments. We have, both for the remote handling system and the detritiation systems, pilot scale technologies, but they're not full TRL matured levels yet, or industrialized solutions. But we are developing that capability, and there is clear opportunity for wider UK industry to get involved there and help us shape what that final solution looks like. And then in other areas of innovation, the sort of the where and the when we innovate leads directly to some key decisions that we have to make to manage our uncertainty. So, of course, JDR has a costed regulated lifetime plan, and it's based on an entirely credible and possible decommissioning scenario. But at this stage, we cannot guarantee that it is the best, most cost-effective plan, because, of course, like all our plans, it is based on a number of reasonable assumptions. Also, the world around us, especially over a multi-decade program, the world around us is just constantly changing, whether that be sort of technologically, politically, economically. We have to remain sort of flexible, open, and robust to these changes, and make sure that we pick or make the right decision at the right time, to avoid that kind of creep you see in these long programs. And particularly perhaps where UKEA may have been more accustomed to that creep during its operational days, in its sort of previous blue sky R&D way of thinking. But in line with our government tranches, we've systematically set out a plan here around these decisions, because we have to arrange ourselves in such a way, because of course we have a finite budget, both in year, in tranche, and for the entire programme. And the questions that define our programme are these pictured here. And importantly, none of them are purely technical. They are all trade-offs between cost, risk, schedule, and long-term outcome. For example, do we fully use this inside-out approach to kind of fully decommission, or do we go part way and then pause for a time to care and maintain and allow for a certain period of decay storage? Another one is, do we detritiate those components I spoke about in the vessel in situ by using the existing heating systems that are in the tokamak, or do we remove those and take them to a standalone tritium detritiation facility? And do we use the waste management buildings that were there for operational purposes for decommissioning, or do we build new ones entirely? Every one of these decisions depends on information that we don't yet have, but we know what we need to find out, and we've set that out in our plan, and in the case that we've clearly made to DESNZ that's linked to our tranched funding. The risk is that if we leave these uncertainties unresolved, they're the things that will drive cost and overall timescale. So our approach, as I say, is to deal with these at the right point in time. And much of this actually focuses around targeted characterization of the waste, understanding where the tritium has got to, and how we manage the waste hierarchy in the most cost-effective and safe way possible. But the silver lining, to get these answers, we will turn to you, UK industry, with a very interesting proposition. So what makes JET interesting and valuable is that it gives us a unique opportunity, a unique environment rather, to solve these problems in. So first of all, our culture. We don't have decades of embedded decommissioning process and practice, and we are willing to adopt potentially some new ways of thinking. Secondly, the scale. Certainly it's not the biggest scale that UK is dealing with, but it's large enough to justify certain technologies. It's a first of a kind environment, and we simply accept, because it's first of a kind, that it may require first of a kind solutions, even if those deployments of potentially lower TRL systems are potentially slower or more expensive. We understand that. Thirdly, severity of the hazard. So compared to many other nuclear sites, some of which have been discussed today, our hazard environment is much lower, much more manageable, which allows us potentially, with our regulator, to discuss trialling some new technologies safely. And lastly, it's our openness, whether that be intellectual property or physically the security of the site. For decades, we've been an open book, and we've welcomed collaboration with the scientific community, with academia, and industrial partners in ways which more constrained organisations just might not be able to. So what that means is JET is not just something we have to decommission, it is a test bed. It's a place where you can develop new tools, new methods, new ways of decommissioning that, as I said earlier, future fusion programs will look to underpin their own decommissioning plans with. So whilst we might not, we may consider ourselves as experts in fusion science and operations, we'll be first to say we're not the experts in decommissioning, and that's where we will look to you, the market, to fill that gap. So some of the opportunities already, you may have seen the strategic management support framework. We have already pulled in lots of industry experts and embedded them within our teams to give us that experience. There'll be opportunities in technologies for waste sort and segregation and disposal, especially around sort of hot cells, robotics and large item size reduction. Opportunities for services in conventional deplant and demolition, and even asset sales and repurposing. But we know we cannot do this alone. We need industry expertise. And so to bring it together, JDR is not just about the end of JET, it's about the start of something much, much bigger. So for the first time, we will be looking with the UK supply chain to take a fusion facility through its entire life cycle, confront the realities of decommissioning and turn those lessons into something repeatable, from a one-off experiment to a global fusion decommissioning blueprint. And that blueprint matters because if fusion is to become a sustainable industrial energy source, not only do we have to prove that we can build it, but finish it safely, efficiently, and at scale. Thank you very much.